Welcome to this conversation about triangles. So we are going to spend a lot of time with triangles, and so this is the first video of the first piece of triangles. And in this first section that we're going to talk about triangles, we're going to really focus our attention on some of the very basic theorems that apply to triangles. So in order to do that, we need to first start with something else. This is not triangular, but we're going to need this information in order to prove some of the theorems, at least one of the theorems about triangles. So we're going to talk about transversals and parallel lines. Transversal, what the heck is a transversal? Well, transversal, if you think of that root word trans, it means cross, right? A transatlantic flight crosses the Atlantic Ocean, right? The transcontinental railway went across the continent. Likewise, a transversal is a line that crosses two other lines, and those two other lines need to be crossed in two different points. All right, so here's a picture. All right, so here are two lines, right? And this is the line that is considered the transversal. It crosses the two other lines, and it crosses them in two different points. In other words, a transversal cannot cross two lines directly where they intersect. That's not a transversal then, okay? All right, so notice I've labeled all these angles, all right, so that we can refer to them. When we have a transversal cutting two lines, and these lines are obviously not parallel, but it's still a transversal, they create different types of angles. And so you need to be able to refer to them as the types of angles they are. We're first going to classify very basically in terms of what are the interior angles and what are the exterior angles. And as you might guess, the interior angles are going to be the ones that are inside those two lines. Can you name them? Hopefully you can. You can just say that's angle C, D, E, and F. So let's just write that down real quick. Well, what does that mean about exterior angles? Exterior angles will then be the angles that are found on the exterior of those two lines, okay? So we've got these two, angles A and B, and we also have these two, angles G and H. Okay, make sure you got those jotted down. Okay, so now let's further classify these angles. Let's think about what are considered alternate interior angles, all right, and alternate exterior angles. And so what makes them alternate is one will be on one side of the transversal while the other will be on the other side of the transversal, okay? So alternate interior angles, they're going to be a pair, and we actually have two pairs. If we're talking about the interior angles, we're talking about the pairs angles E and angles D. They're alternate interior, and angle C and angle F are alternate interior. Okay, likewise with alternate exterior angles, they're going to be same thing. Exterior angles, one is going to be on the top and one is going to be on the bottom, all right? And they're going to be on opposite sides of the transversal. Okay, so we would have angle A and angle H are alternate exterior angles. Angle B and angle G are alternate exterior angles. Okay, make sure you jot those down too. Okay, the last two kinds of angles we're going to talk about are consecutive interior angles and what are called corresponding angles. So consecutive interior angles are angles that are on the inside on the same side of the transversal. Okay, so if you're looking on the inside here, the interior angles, but on the same side of the transversal, I have a pair of angles C and E are consecutive interior, and also angles D and F. Now corresponding angles are angles that are just in the same position on both lines, okay? So if you're looking at this, you can think about corresponding angles as like the upper right hand angles or the lower left hand angles, okay? They're in the corresponding position, but on either line. So think about angle A. Angle A is in the upper left, and so the angle in the upper left on this line is angle E. So angle A and angle E are corresponding angles. There are four sets of those because there are four positions. So can you name them? A and E, that's also a station, isn't it? B and F, C and G, and D and H. All right, make sure you got those down. All right, so now we're going to really shift gears, and we're going to still use this relationship, two lines cut by a transversal, but, ready? These lines are not going to be parallel. And what that does is it creates relationships within those angle relationships, okay? So let's change our drawing so that the lines now look parallel. Okay, so now we have two lines that are parallel. We know they're parallel because we have these markings. You'll either see them as arrow markings on the lines or just triangles on the lines, and that just designates them as parallel to each other. Okay, so when I have two parallel lines cut by a transversal, that makes things very neat and clean and wonderful, okay? When this is true, and it's an if and only if situation, if these lines are parallel, then these relationships occur, okay? Corresponding angles will be congruent. So that means that angle 1 will be congruent to angle 5. Angle 3 will be congruent to angle 7. Angle 2 will be congruent to angle 6. And angle 4 will be congruent to angle 8. Okay. Okay. Also, alternate interior angles are going to be congruent. Okay. So, angle 4 and 5 will be congruent to each other, and angle 3 and 6 will be congruent to each other. Also, alternate exterior angles will be congruent to each other. So, if the alternate exterior angles are congruent to each other, we know that angle 1 will be congruent to angle 8, and angle 2 will be congruent to angle 7. All right, that last set is going to be consecutive interior angles. And what do you think about them? I might have kind of tricked you, because consecutive interior angles are not necessarily going to be congruent. In fact, there's only one case in which they are congruent, and that's if the transversal is perpendicular. What is true, and you can probably look at this diagram and see, notice that if you have any kind of slant to that transversal, you're going to create an obtuse angle and an acute angle here, right? Well, the relationship is that these two angles then are supplementary and not congruent. Okay, so instead of being congruent, those two pairs are going to be supplementary. So we could say that the measure of angle 3 plus the measure of angle 5 is going to equal 180 degrees. We can also say that on the other side. The measure of angle 4 plus the measure of angle 6 is going to equal 180 degrees. Now, knowing this creates all kinds of great problem solving opportunities. But the one thing you've got to remember is these relationships hold only if these lines are parallel. Okay, so, and it goes both ways. So if we know that the alternate exterior angles are congruent, we can definitely say then that the lines are parallel. All right, I'll see you next time.